All right, so we're going to be talking about solving special systems of linear equations today. And before I start doing an example, I want you guys to try to solve this system over here, y equals 2x plus 1 and y equals 2x minus 5, using any method. You can use, I don't know, graphing, or you can use substitution, elimination, whatever it takes, okay? Just use what we learned, see if you're able to do it, and see what happens, okay? Give you some time there. Pause the video. All right, so I hope you guys try it, and you guys notice that something happened to it, okay? Something weird happened to it. So let's solve it. I'm gonna be solving this by using basically substitution is easy. Usually when you have something like y equals to something and y equals to something, it's easier to use substitution. And again, y is equal to y, right? So we did before, so we know that those two are equal to each other. So we know also that this 2x plus 1 is also going to be equal to 2x minus 5. So let's write it down. 2x plus 1 is equal to 2x minus 5. We got right there. Right? Now, subtracting 2x to both sides of the equation, and something happens. 2x and negative 2x cancel each other, and 2x and negative 2x cancel each other. Now we got 1 is equal to negative 5. And that is something wrong here, right? We don't have any variables, and we got a statement that is not true. 1 is never going to be equal to negative 5. So it's a false statement. When you got something like that, it means that this equation, okay, this system of equation has a no solution. Why do you have a no solution? If you guys remember, okay, parallel lines in the previous chapters, okay, these two equations are parallel lines. See, they have the same slope, different y-intercepts. They are parallel lines. And if you know the definition of parallel lines, okay, you know the parallel lines never cross each other. So these two lines are never going to intersect. And remember, to find the solution of a system of equations is basically where the two lines intersect. And these are never going to intersect. So it means that basically if you have parallel lines, it means that, hey, that's a no solution because they never cross each other. Those lines never cross each other, so no solution. All right, let me see if you guys can do the next one. I'm gonna give you another one here. Let me flip the page. Let me give you example B. Let's write down negative 2x plus y equals to 3, and negative 4x plus 2y equals to 6. Pause the video, see if you're able to handle it. All right, so we got these two equations here. Probably when you have it like in standard form, like x plus some y and equals to our constant, the best method probably is to use elimination. And in this case, I need to create basically two opposites. So there's many ways you can create the opposites, but I'm gonna go and multiply the top one by a negative 2. Because if I multiply the top one by a negative 2, when I multiply negative 2 times y, I get a negative 2y, which is the opposite of 2y. So remember, if you multiply by a number here, you gotta multiply all of the terms of the equation by that number so you can keep the balance, okay? So negative 2 times negative 2x, that will be positive 4x. Negative 2 times y, that will be negative 2y. And negative 2 times 3, that will be a negative 6. And this one, well, this one stays the same because I have the opposite right here, right? 2y and negative 2y. So I got negative 4x, positive 2y, and we got negative 6. Now we're gonna be adding those together. 4 and negative 4, well, that's a 0. Negative 2 and 2y, well, that's a 0. And this one, oh, that's a positive 6, sorry. That's a positive 6, right? I made a mistake right there. So negative 6 and 6, right? That will be also a 0. So I made a mistake here. I copied it wrong. That was a positive 6. So what we got is 0 is equal to 0. Hey, that's a true statement, okay? This is always true. So it's not a no solution. It's different. It's an infinite amount of solutions. Infinite amount of solutions. So infinite amount of solutions. It means basically that these two equations are the same. They're on top of each other. It's the same equation, written a different way. So that means that, again, if both equations are the same, are equivalent, that's what happened, right? They're the same. So that means that we have infinite solutions. So those are two special cases. So again, you have the normal case where you have one solution where the lines cross, you know, in one point, and they share one solution there. You got parallel lines, they never cross, that means no solution, and you have the same equation, you know, top of each other, so they're sharing all the solutions on that infinite amount of solutions. So I hope that would be helpful for you guys, and please do your assignments.